Why bodies float? In this topic, we will learn about thrust, pressure in fluids, pressure exerted by gas, and liquid pressure. Thrust. Press your thumb against a piece of paper. Now press the pointed end of a pin against the same piece of paper. Do you notice any difference? When pressed, the pointed end of the pin passes easily through the piece of paper. That does not happen when we press the thumb against the piece of paper. Keep a heavy book vertically on a sandbed. Now keep the same book in a horizontal position on the sandbed. What difference do you notice? The book goes deeper into the sand when kept in a vertical position than in a horizontal position. In both the positions, force exerted on the sand is the weight of the book, but effects produced are different. Why? In both the above cases, force is acting perpendicular to the surface, that is, paper or sand. The force acting on an object perpendicular to the surface is called thrust. Even though thrust is the same, it produces different effects. This is because the effort of thrust depends on area on which it acts. The thrust on a unit surface area is called pressure. Formula for pressure is pressure is equal to thrust upon area. SI unit of pressure is N upon m square. It is also called Pascal, PA, in honor of the scientist Blaise Pascal. About Blaise Pascal. Blaise Pascal was a French physicist and mathematician. He formulated what come to be known as Pascal's law of pressure. He modified experiments on atmospheric pressure by constructing mercury barometer and measuring air pressure. He invented the syringe based on principle that came to be known as Pascal's law. Activity. Calculate the pressure exerted in following position of wooden block. Given the value of length of the wooden block is 80 cm, breadth is 50 cm, thickness is 20 cm, and weight is 500 N. Now it is kept in vertical position. Note that N is stand for Newton. Also calculate pressure when the wooden block is kept in horizontal position, which its surface 80 cm into 50 cm touching the floor. Is the solution for the example. Given thrust F is equal to 500 N. L is equal to 80 cm, that is equal to 0.8 meter. B is equal to 50 cm, which is equal to 0.5 meter. H is equal to 20 cm, which is equal to 0.2 meter. As we know, the formula for area is breadth into height, that is 0.5 meter into 0.2 meter. That gives an answer 0.1 meter square. Now pressure is equal to thrust upon area is equal to 500 Newton upon 0.1 meter square. 5000 Newton per meter square or 5000 Pascal. The pressure exerted in the vertical position of the block is equal to 5000 Newton per meter square or 5000 Pascal. Area is equal to length into breadth is equal to 0.8 meter into 0.5 meter, which gives an answer 0.4 meter square. Now pressure is equal to thrust upon area is equal to 500 Newton upon 0.4 meter square which gives an answer 1250 Newton per meter square or 1250 Pascal. The pressure exerted in the horizontal position of the block is equal to 1250 Newton per meter square or 1250 Pascal. Similarly, measure length, breadth, height and mass of a rectangular tiffin box. Find the weight of the box and calculate pressure in two different positions as above. Solution. Let length is equal to 0.25 meter. Breadth is equal to 0.1 meter. Height is equal to 0.05 meter. And force is equal to W is equal to 0.5 Newton. As area is equal to breadth into height, 0.1 meter into 0.05 meter. It gives an answer 0.005 meter square. Therefore, pressure P is equal to F upon A is equal to 0.5 Newton upon 0.005 meter square. It gives an answer is equal to 100 Pascal. And area is equal to breadth into height, so 0.25 meter into 0.1 meter. It gives an answer 0.025 meter square. Therefore, pressure P is equal to F upon A is equal to 0.5 Newton upon 0.025 meter square. And the answer is 20 Pascal. Large pressure is exerted on smaller area while less pressure is exerted on larger area by the same object. Pressure in fluids. Activity. Take two rubber balloons, fill one with water and blow air into another. Now prick both balloons with a pin. What do you observe? Water and air both come out of the balloons. Air escapes quickly compared to water, produces a loud sound. Liquids and gases are called fluids, that is, the substance which can flow. Fluids exert pressure on the base and walls of the container that holds them. It is due to the weight of fluid. Fluid also exert pressure on all bodies immersed in them. Pressure exerted in any confined masses of fluid is transmitted undiminished in all directions. Liquids are differentiated from gases by their properties of positioning a definite volume at definite temperature. Pressure exerted by gas. Take an empty can. Pour small quantity of water in it. Boil this water for a few minutes until the steam has driven out the air. Now close the can with the stopper tightly. Allow it to cool by pouring cold water over it. What do you observe? The can gets gradually crushed. The steam inside the can condenses to form water as the can cools. Therefore, the pressure inside the can becomes much less than the external pressure of the air. Hence, the can gets crushed. The air exerts pressure in all directions. The pressure exerted by the gas in the coldest container is due to collision of gas molecules with the walls of container as molecules are in the state of random motion. The force exerted on unit surface area by the weight of air above it is the atmospheric pressure. It is also the result of collision of air molecules with any surface. The atmospheric pressure at a place depends on its height above the sea level. As we go higher, atmospheric pressure decreases due to thinness of air. At sea level on the Earth's surface, the atmospheric pressure is about 10 raised to power 5 Pascal. Even though the pressure acting on you is so large, you don't feel it because the pressure of blood and another fluid present in our body balances the atmospheric pressure. Think, why? Some people feel their ears popping at the top of the mountain. Atmospheric pressure decreases with altitude. At the top of a mountain, it becomes less than the internal pressure in the air. Hence, some people feel their ears popping at the top of the mountain. Some people feel breathless as they climb higher and higher on a mountain. Atmospheric pressure decreases with altitude. Hence, some people feel breathless as they climb higher and higher on a mountain. We can enjoy cold drinks or fruit juices with the help of a straw. But can we imagine drinking juice on the moon using a straw? When we suck air in the straw, the pressure of the air in the straw becomes less than that of the outside air on a cold drink or fruit juices in a bottle or the glass. Hence, the cold drink or fruit juices rises in the straw and enters your mouth. We can drink it. But there is no atmosphere on the moon. Hence, it is not possible to enjoy cold drink or fruit juices on the moon by using straw. People are often advised not to carry fountain pens while traveling by air. The ink in the fountain pen, filled at a sea level at atmospheric pressure, may comes out through its mouth while traveling by air if the outside pressure become less than the pressure in the ink holder of the pen. This can spoil the clothes, purse or bag. Hence, people are often advised not to carry fountain pens while traveling by air. Liquid pressure. Have you ever had a swim in water? You must have observed swimmers. While swimming, weight of the body is supported by water, that is, liquid pressure. The pressure at any point under the liquid is due to the weight of liquid column above that point. Activity. Take 3 plastic bottles of different sizes and different diameters and mark them as 1, 2 and 3. In bottle number 1, make 3 holes at the same height. On bottle 2 and 3, make 3 holes at different heights and close all the holes of the bottle with tape. Fill the bottles with water. Remove the tape from bottle 1. Observe the flow of water from the holes. Write down your observation. Then remove the tape from bottle 2. Observe flow of liquid from different holes at the same time. What difference do you notice? Similarly, observe flow of liquid from different holes of bottle 3. What difference is there with respect to bottle 2 and 3? What is the reason? Repeat the same procedure with another liquid. What changes do you notice? The pressure is exerted in a liquid on all sides of the container. At a given depth, pressure remains the same in all directions. Pressure is independent of size and shape of container, but it depends on the height or depth of the liquid. Pressure increases with depth. It also depends upon density of the liquid. Visit a dam nearest to your city or town. Observe the walls of the dam. Why are walls of the dams made strong and thicker at the bottom than at the top? The pressure at a point in a liquid is proportional to the height of the liquid column above it. Hence, the pressure of water in a dam is much greater at the bottom of the dam than at the top. To withstand this high pressure, the walls of the dam are made stronger and thicker at the bottom than at the top. Summary. The force acting on an object perpendicular to the surface is called thrust. Large pressure is exerted on smaller area while less pressure is exerted on larger area by the same object. The atmospheric pressure at a place depends on its height above the sea level. As we go higher, atmospheric pressure decreases due to thinness of air. The pressure at any point under the liquid is due to the weight of liquid column above that point. That is all in this topic. Keep learning.